Hi, everyone, and welcome to Behind the Layers, Strategies for Understanding the Technology that Supports You with our featured speaker, Thomas Moore. Thomas is a software engineer currently at Microsoft Corporation with 13 years of professional experience. He has introduced features and improvements across Microsoft Word, Mozilla Firefox Reality, Microsoft Edge, and Windows Internet Explorer. He holds bachelor's and master's degrees in computer science from Washington University in St. Louis. Thomas is passionate about collaborating to build world-class software products and increase the number of competitive Black software engineers in the tech industry. Now, that's Thomas's bio, but I have a personal relationship with Thomas as he recruited me, and we met on the campus of Florida A&M University in Tallahassee. And for the longest, I didn't know that Thomas was not a Rattler. So that just goes to show how well he invests and builds community throughout the HBCU community and in the software engineer industry, supporting Black engineers specifically. I could talk all day about Thomas. I've attended some of his ramp up sessions for how to be a better engineer and how to land a job. I've also talked with him personally as a friend and a mentor. He's someone who has groomed me and taught me some things that I know into the software engineer. Into my software career. And he's back at Microsoft. So I'm excited to have Thomas with us today. Beyond the Layers, Strategies for Understanding the Technology that Supports You. Thomas, I'm handing it over to you.
All right. Well, thank you, Greg. That was quite the intro. And thanks to everybody who are here now. I feel like it's really honored and privileged to be able to give this talk.
Awesome.
So I'll get started. I am gonna gloss over this slide because Greg did a better job than I would, right? In sharing my story. I guess the one thing I can't remember if it was in there. I am from St. Louis, and that's something I guess I'm really proud of. But everything else, I think this is just my bio in picture form. So I'll keep going from there. So I'm going to be upfront with this talking like what I want to accomplish. And I'm going to call this my money slide. So if you don't take anything else from this presentation, please at least take this with you. That a technologist is someone who goes beyond the layers and they understand how their solutions fit in a larger context, resulting in building resilient solutions and continued personal growth. So I use the word technologist here pretty liberally because I'm assuming that everybody here is a software engineer in this workshop. So I make this statement and I think it can apply to data scientists and QA engineers or product managers or even students. Basically anybody who is modifying or creating something new in technology. So I'll read it one more time. A technologist who goes beyond the layers understands how their solutions fit in a larger context, resulting in building resilient solutions and continued personal growth. So for the rest of this presentation, I'll try to explain this as best as I can. I'll introduce some fundamentals that I think are relevant no matter where we are in the software stack. And after that, I'll share some resources for going beyond the layers. And I'll end by sharing some stories from my career and come up with some ideas for how this could apply to you. And I will say too, I know we don't have as many people who are here, so I am open to being a little bit more flexible with how I do this talk. So at first I was going to say, keep your questions toward the end of certain parts, but please feel free to interrupt at any point if anything is unclear or if you just have questions. All right, I'll keep going. Okay, so what do I mean by going beyond the layers? I don't think it's about doing one specific thing, but it's more about the approach for the type of work that you do. When you go beyond the layers, you look at the software that you use or write as a piece of a much larger puzzle or a much larger system. You recognize that there are many things that come together to make your stuff work. And depending on the work that you do, you recognize that there is also, or there could be other software that depends on the work that you do as well. So going a little bit further, I think going beyond the layers involves considerations for things that are outside of your control, but your understanding of those considerations will help you make better decisions about the things that are in your control. Going beyond the layers is not a destination, right? It's a journey of continually learning and growing and continually expanding in not only your knowledge, but also your ability to apply it. I think going beyond the layers is less about developing expertise or even some big titles. It's more about developing awareness that there are details outside of the details that you know. And you don't have to know or understand all of those details, but you know those details are there and that those details are important. So one way that might make this a bit more concrete is to consider how some, I guess, engineering shops, they have front-end engineers or they'll have back-end engineers. And then some places have roles where they blur the lines between them and they have full stack engineers. So I'm gonna make up this thing called whole stack engineer. So to be clear, I made this up, so please don't call yourself this out in public. But in my mind, a whole stack engineer has a growing understanding of the software that they build upon, whether it's a UI framework or operating system APIs. They can make appropriate considerations for how their software interacts with hardware, maybe not enough to be a hardware engineer, but enough to have some kind of mental model of what's working in the layers below. They can think about the whole stack from hardware components all the way up to user interaction. So why do I think this matters? I think having the ability to go beyond your layers basically results in building better software. So you'll have a more informed design and architecture because you have reasoned about how your software fits in the big picture. You've investigated your dependencies and you understand how other layers depend on you. You will have higher quality software because not only have you thought about your issues and bugs, but you've also thought about the issues and bugs in the layers below you and maybe even above you too. You'll have predictable performance because you have thought about how the hardware and software components work together. You know which parts are faster and which parts are slower, and you can make design decisions based on them. And then lastly, you'll have solid security because you know how data flows in and out of your code. You know how much trust to put in the layers above and below you. So with that in mind, I want to establish some shared fundamentals that I think will be relevant for everybody in the room. These fundamentals are basically computer architecture. And I think having a grasp on computer architecture is important to go beyond the layers. So why do I think that? Well, at the end of the day, no matter what any of us do with software, we will always be constrained by the hardware available to us, no matter where you are on the stack. So having an understanding of how these components interact will enable you to have a better understanding of how your code interacts with these components. All right, so I will talk about computer architecture in three main parts. We'll talk about data, execution, and the operating system. So here, first, I call out three ways that data plays a role in computer architecture. So first with network. Networking is basically just one machine talking to another machine. And of course, it can be wired with Ethernet or wireless with Wi-Fi or cellular with, I guess, 3G or LTE or even 5G as it's being rolled out now. And then there are many protocols that determine how networking communication happens, like TCP versus UDP. And these protocols meet different needs like reliability versus speed. Next, we have the hard disk. And why is that important, right? We need a place to persist data across sessions like your operating system files or files for your programs and apps, or even user data, like the files that you store for what you create. And of course, there are older technologies like in this picture with magnetic disks that spin around when you need to read and write information. But there's also newer technologies with SSDs that are based more on integrated circuits and NAND gates. And also that same technology is used for storage in your phone or your tablet. And then lastly, I want to talk about RAM. So as opposed to persistent storage, RAM is volatile storage. So as soon as you cut off the power, it loses its data. So why is that important? So RAM as volatile storage is like a middle of the road solution um, in terms of performance and cost for the CPU to work with, which I'll talk about in the next slide. So for execution, I'm going to just bring up two types of hardware. So first, there's a CPU. And there are many, 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 many subcomponents to the CPU that I will not cover in this talk. But the main thing I want to talk about now are instructions. Instructions are basically what the CPU executes. All software is eventually reduced down to a series of instructions that come together to make the system run. These instructions are a set of simple or maybe even complex operations that manipulate binary data. Some instructions are faster than others, and CPU frequency and clock speed are one way to measure how fast this can happen. And then next, there's the GPU, the graphics processing unit. The primary output interface for a machine is visual, right? Like it's what we're looking at now. But visual output can be complex. Now, CPUs are pretty generic and can run a wide range of types of instructions, but GPUs are very specialized to a limited number of operations that support graphics. Many of these operations have foundations in linear algebra, which work naturally for calculating in 3D in 3 dimensions. So even though the primary use for a GPU is graphics, its efficiency for doing math makes it useful for other things like mining for Bitcoin. And for those who are paying attention, note that the first two breakdowns in architecture that I'm talking about is data and execution, which is basically data structures and algorithms. And then lastly, I want to talk about operating systems. The OS is the layer of software that brings together the hardware components. There is software below it in the stack, like drivers written for hardware, and there's software above it in the stack, like all of the applications that we use every day. There are many operating systems in the world, and they all exist to work in different ways for different hardware. So here on the slide, I have logos for many popular desktop and mobile operating systems. But there are more operating systems than that support other types of hardware, like TVs or traffic lights or components in airplanes. So once again, there's no way that I can cover all the things that an OS does. But I will cover is that it is truly responsible for managing all the resources that the computer has. So it could be managing hardware, like all the components we just talked about in the previous slides, and those that I did not mention, like sound coming out of your computer or input from your keyboard or mouse, or maybe even a touch screen. And the OS could also be managing access to resources, like for systems that have more than one user. And it manages how the software on the computer works together by providing APIs to safely use system resources. So in computer architecture, I just covered data execution and the operating system. And again, I bring this up because no matter what you do, it's going to come down to these. You could be doing mobile development on a phone, or desktop development, or cloud development in AWS, or building a service in a Docker container, or even running queries on a cluster of databases. But no matter what you're doing, it'll still be connected to these things some kind of way. You won't be wasting your time if you have an understanding of computer architecture and how it connects to your work. So I'll pause here briefly to take one or two questions if we have any on computer architecture. And if there's more, well, we can make room for that too. And if there are no questions, I'll keep moving.
All right. Anyone in the audience, feel free to come off of mute or come on the camera and ask your question. Thomas, I do have a question.
Yep.
In terms of computer architecture and operating systems, exactly how important is it that software developers understand the architecture and the operating systems that they're using when they develop?
I would say it depends on how close the code you're writing is to the operating system, right?
Okay.
So if you're writing code that
Mm.
is manipulating files right on the file system, right?
Okay.
Then it'll be really important to know and understand um, as best as you can what the OS is doing with those files.
Okay.
Because if you get it wrong, right, and you end up responsible for losing data on the machine,
Uh-huh.
well, that'll be one easy way to keep people from using your software,
Okay.
right? So I would say the closer you are to the OS in your app, then the more you want to understand what's going on underneath. So
Okay. That's an excellent answer. Thank you.
yeah,
All right. Awesome.
all
Any
right.
other? Go ahead.
How about say I'll keep going if there's no other questions.
All right. Please continue. And if anyone has a question, feel free to drop it into the chat.
Yeah, yeah.
All right. Awesome.
All right. So now that I've covered these fundamentals, there are many paths that you can take to go beyond the layers. You can always go deeper in understanding computer architecture, like I said. But even beyond that, there's so many layers that is outside of your scope for you to learn and to go beyond the layers that you know. Now it's 2021, right? And we have access to much more information than would have been available 5, 10, and definitely 50 years ago, largely thanks to the internet. And so I've listed here many ways that you can learn. Most of this list is a bit more passive learning. So like reading or listening or watching information from someone else. And those are all really important. So take advantage of the ones that better match your learning style or the amount of time you have dedicated to learning. Um, but toward the bottom of the list, though, I want to highlight that these involve more active learning. So sometimes going beyond the layers isn't just learning about them. It might mean playing with them. So if you have permission to look at code outside of your layers, go ahead and debug it, right? Or run that code under a profiler to examine maybe some performance characteristics. Or maybe even try some experiments, right? Change something and then see what happens, right? Like, did it break? Did you make it better? Did you make it worse? I think when you have the space to play in other layers, you should take advantage of it. You'll learn a lot in ways that I think will stick longer. Oh, sorry. So, sorry, I clicked the wrong button. So there we go. So now that I've talked about that in general, I want to shift gears and tell a story about about my journey in my career beyond the layers. The story I'm going to tell is from earlier in my career as we were developing Internet Explorer 11. One of my mentors invited me to join him on a project to implement WebGL for IE. So if you're unfamiliar, WebGL is a JavaScript API for rendering 3D content inside of a web browser. So if you've ever played a 3D game inside of the browser, then there's a really good chance that the developer used WebGL to build that, to enable the app to do that. And if you ever ran that inside of IE or Edge, then there's a good chance that you were using code that I wrote. So for this project, I was given the task to build all of the texture APIs. So what's a texture? A texture is basically visual data that can be mapped onto some kind of 3D object or 3D description. So for instance, on this slide, I have a texture for a basketball. So if you look, the image on the top left, that's the texture. That is what it would look like represented on the GPU or on disk. And so as you can see, it is a flat 2D picture, but if you take that 2D image and you project it onto a sphere, it would look like, well, a basketball, right? When rendered into a 3D scene like you see in the bottom right. So in building the texture APIs, I provided a way for a web developer to get these textures from the web page to the GPU. Now, coming into this project, I did have some experience in IE because at that point, I was on the team for 4 years, but I did not have any graphics experience. So this project pushed me to go beyond the layers. So first, let me tell you about the layers that were involved. I made this simple diagram on the slide to show the whole stack that was involved. But I guarantee you there were many more layers than what I could fit on this slide. The arrow points at where my team and I were in the stack. As in, and where the arrow is pointing, this is where we wrote the code to build WebGL. But as you can imagine, we still interacted with all other pieces that you see here above and below us on the stack. So how did I do it? How did I learn and grow and go beyond the layers? First, my mentor loaned me a book that covered the basics of graphic programming. This book was really thick and I did not read the whole thing, but I did go over the first few chapters. And then I started learning about WebGL itself by finding some tutorials online. There were tutorials that taught web devs how to use this API. Now, I'm not a web dev, but I needed to understand how they were using it because I was building a layer for them. Next, I started learning about DirectX and its APIs by reading documentation about it. And DirectX, if you don't know, is the set of graphics APIs and capabilities that is built into Windows and Windows devices like the Xbox. So I needed to read documentation for DirectX, and I need to read documentation for WebGL, and then a related technology to WebGL called OpenGL. Because all of this documentation described the behavior that I needed to build and build upon. As I learned all of that and started writing code, one of the things that I learned was that copying texture data from RAM, where I guess a web developer is, to the GPU was expensive. So think about when you're playing a video game and you always have to wait for the game to load at certain points. There's a lot of things that happen during that time. And one of the things that happens is loading texture assets to the GPU. So knowing that constraint and learning how that constraint worked helped me to make some decisions in the code that I wrote because I wanted to make this as efficient as possible. Because if I didn't, then websites that used WebGL and IE would be slow. And I didn't want to have that. So I needed to go beyond my layers in order to do that. So what tools did I use to learn and grow beyond the layers? So first, definitely a debugger. I debugged a lot in working on this feature. And not only debugger for the code that I wrote, but even debugging code below me. And then also using the web dev tools to debug websites who were also building on top of the technology that we were building. With DirectX, they provide diagnostic tools that were really helpful, especially when I hit some kind of weird error or if my program crashed and I didn't know why. Those diagnostic tools will give more information. And then probably more importantly, I had two mentors who taught me what they knew. Learning from them was much faster than just going at it by myself because they helped direct me toward the relevant things that I needed to learn. And I was able to learn from them when I observed them doing their jobs too. So I have many examples over my career where I went beyond the layers and looked at the whole stack to solve problems. Now, to be clear, not everything I did required that kind of thinking. But being able to do that gave me opportunities to take on other projects throughout my career. And specifically, this experience with WebGL ended up giving me future opportunities to participate in projects with virtual reality because many of the layers between 3D graphics and virtual reality are shared. And I had already put in the work to learn it, some of these layers while working on this project. So I've shared my story with you, and now I want you to take a moment, reflect on you and your own journey. Think about something you've worked on before, or maybe working on now.
Okay.
Could you make your own diagram similarly to what I made on the previous slide? Imagine all of the layers in your whole stack, right?
Mm-hmm.
What would they be? What layers are yours? And what layers do you depend on?
Mm-hmm.
And what layers depend on you?
Okay.
And with what you've imagined, find a way to articulate or visualize it, right? It could be drawing a diagram or writing a paragraph,
Mhm.
or creating a flow chart, just whatever works, right?
Mhm.
But however you do it, let that guide you for what it could look like for you to go beyond the layers, right? As
Okay.
you identify all these different things, it might make it easier um, to find the things that would be good for you to learn and go deeper into.
I'm going to go ahead, please, please.
Oh, okay. As I close out, I want to help jumpstart what some of these journeys could look like. So, for instance, if you're a web developer, think about what happens every time you add a new div element, or maybe even 10 of them, to a web page. Does that impact how much memory you use? The answer is yes, right? So maybe a better question is like, how does it impact it? And how does adding a new framework affect the page, whether it's adding more network bandwidth, or using more memory, or taking up more CPU? If you're a data scientist, how does Python or R work? What do they provide in order to help you reduce costs for larger queries? Or if you're a backend engineer, what do you understand about the code that's depending on you? Do they have to use weird patterns in order to use your code? If you're a mobile app developer, how does your code impact the phone or the tablet's battery life? Or maybe even its data usage? Or if you're a game developer, how does your game engine work? What opportunities do you have to learn about the improvements that they make with their upgrades that you could take advantage of? And if you're here and you're still in school, well, what opportunities do you have to better understand the ideas that seem unclear today with what you've learned so far? So maybe it could be a class that you register for next semester, or maybe it could be an extracurricular to participate. So this is by no means an exhaustive list. This is just what I came up for this presentation. There are at least as many different journeys as there are people in this workshop. So please, please be empowered to create and to imagine what that looks like for you. I want to end with the same statement that I started with, um, which is a technologist that goes beyond the layers understands how their solutions fit in a larger context, resulting in building resilient solutions and continued personal growth. And so hopefully reading it that time or hearing it that time, it makes a bit more sense than it did when I read it the first time. So I want to open up the floor and take questions, or if anybody wants to share anything from their journey. And if we can't think of anything, I do have an exercise that we could try, and see how that works. So Greg?
Thank you, Thomas. We definitely appreciate it. And I was jotting down some notes. Some of the things you said had me thinking back when I was a web developer in the different layers of the stack. I know we got Mr. Johnson on the line, and he shared that he does websites and he's a developer as well. So Mr. Johnson, if you don't mind coming off mute and telling us a little bit about your stack and having a discussion about what you think it means to go beyond the layers on your technology stack, if you don't mind.
You put me on the spot. Okay. The layers that I usually have are similar to what Thomas has, as far as the HTML, CSS, but then my next layer would probably be Apex, which is a language similar to Java in Salesforce. Below that, I'm probably out of my depth because I'm new to the area, so I'm not sure what operating system they're using. But I would think going beyond my layer, as far as this is concerned, would be probably lateral, because the way we build our system, we have other people supporting other components, and so we call those components, and sometimes they are upstream. So we get stuff from them. And so yeah, I would think that, and I've been told this, just to learn about how other people are putting together their components, so when we receive the information, we know what we're getting and maybe why it didn't work the way it was supposed to. We can suggest to them, oh, maybe you could look at this. just to be aware, like you said, cognizant of
Yeah.
what other people are supporting. You don't have to know the details, but you have to know how you're receiving it. So
Right.
So one thing that you said, and Mr. Johnson, was going lateral in your technology stack, and we're talking about looking beyond the layers, right? And you said you're fairly new to the environment that you're working with, so you're not sure of the operating system. I think those are challenges that all web developers face when it comes to new software stacks. I'm a data engineer, right? And so one of the things that it means for me when you say go beyond the layer, and I mentioned this to Thomas before, is that when we're dealing with virtual environments where we have tokens that are being allocated for automation jobs or certain, like some things like that, or we're running queries in the cloud against big data sets or something like that. And one of the things that I have trouble with personally is being able to relate exactly how much CPU, how much memory is being utilized when I submit a query, depending on the size of the data, right? So going beyond the layers for me means that if I can have a better understanding of the hardware or a better understanding of the memory space, then I'll be able to better predict the performance of my query and data.
Yeah, you don't want to get on their bad side, on the database people bad side.
Because data is very important, right? And so I think that if I can relate data to web designing and software development, it's a lower level part of the technology stack, right? And so if you are talking to the front end engineers who are developing the UI and the UX and the experience for the users, having insights into why they design things in particular ways or what they expect the user experience to be like, I think is instrumental from a data perspective, because we can look at, is the user actually on that path? Is the user on the happy path, or is the user on a journey that deviates from the experience that the UI engineer expects them to have, right? So that's a very a dynamic conversation that we're having here. But I'll ask you what your perspective is on that, Mr. Johnson or Mr. Moore, Thomas.
I will. I do want to point out I think it was an interesting basically the word lateral that Mr. Johnson brought up, where that it's not always like this monolithic thing when you think about software, especially if you're looking at cloud technologies or anything that involves multiple machines. There won't be, it's not just one single stack that you have to deal with. And so, like, the layers analogy works great for creating a slide deck. But it is going beyond like the scope of control that you have with the software that you write. And so whatever that looks like for you, I think is worthwhile to explore, which yeah, so I thought that was a really good stretch of the analogy. So yeah.
And that's probably more common, like you said, than just a straight up and down vertical. Yeah.
Yeah. Yeah.
Excellent feedback there. And thank you for the dialogue, Mr. Johnson. So we have a question from Audrey Ballard. And the question is, do you have your own web developing company? Mr. Ballard, or Mrs. Ballard, rather, I'm sorry. You can come off of mute if you'd like. Wasn't sure if you were asking that question to Mr. Johnson or Mr. Moore.
Either one. I've just seen, supporting minority businesses. If either of you have your own web developing company where you develop websites, or just seeing if you are either working for an organization or do you have your own personal business. So that's what I was just seeking.
I I do not. I think like a while when I was in high school and college, I did some of that stuff. But once once I started working full time, I started to do less of that because I didn't have the time that I did before. So I actually tried not to use computers outside of work, but I do support this industry for the record. But yeah.
This is Joe. This is Mr. Johnson. I have tried that. I've dabbled in it, and you can get in the deep end pretty quickly where somebody wants some kind of technology or component that you may not be familiar with, like a shopping cart. You have to build that or something like that. And so I've dabbled in it, but as Thomas said, if you have a day job and now you're going and do this in the evening, it can get really time consuming to figure out how to do that. But I understand your point, Ms. Ballard, about, you know, having some technologists that are Black behind a business, and we really need to do that, which is why I try to mentor and be the coordinator of my chapter's HSCC, the high school computer competition, because those kids have the time.
Okay, thanks for sharing.
Thanks for asking.
And that's an excellent question, Ms. Ballard. And thank you for your response there, Mr. Johnson. In terms of having your own business, what do we think going beyond the layers looks like for an entrepreneur or someone who's a software consultant versus someone that works for a corporation? Because when I'm working for a corporation, my scope may be limited to a particular software product, right? But when I'm working as an entrepreneur, one of the things that you might begin to see is that the solutions are diverse, right? So one day you may be working on a website with a shopping cart, and the very next day someone may say, hey, let's build a social media app or something of the sort, right? So I just would like to know from your perspective, Mr. Moore, and anyone in the audience, feel free to chime in. What does going beyond the layers look like from a corporation to a consultant or an entrepreneur?
So I would say for a consultant, basically your whole job is going beyond the layers, right? Like, in fact, I guess in some ways you ain't got no layers, right? Like your role, your job is to come in and provide solutions for another company or another organization, another individual. And so a lot of that does involve like coming in, understanding what the existing systems are, and then either modifying, augmenting, whatever, in order to meet their needs. So that role, that type of role, like being a consultant, is inherently a learning job. Now, you can say that about almost anything, but specifically for a consultant, like that role involves flexing that muscle a lot more than you might have if you work on, say, like the same software product for 10 years, right? So that's my response to that. And then for entrepreneurs, I think that's interesting because with entrepreneurs who are building something new, another part of the conversation is also having clarity around what you're building. And so that might go hand in hand with like understanding what you're building and then understand what technologies are available to you to build that. And so then like you're learning again, but in a different way, to understand like what things are available to you, like if there are other things that already provide some solutions that you need, whether it's something that you're building on to do something else in the business or something that you're building on for like the business, like if you're building something on top of something else that you're intending to sell. Maybe that's a way to put it. So like you need to build clarity around like what exactly do you need, because then that'll determine the things that you can build on top of in the layers below you. So those are my two answers for that.
Oh, Mr. Johnson.
Yeah, if I could chime in. I did my kind of consulting or, trying to be a web entrepreneur. I did that in order to gain some skills that I couldn't use or couldn't gain at work, because there was so much competition to try to get on the new stuff. I kind of impressed some of the bosses at work that I decided to learn some of this stuff on my own. I might not have used exactly what I learned on my own completely like plugged in at work, but they knew that I could learn. They knew that I could get something new. So that was, I leveraged what I learned as an entrepreneur to get to a better position at work. So that was my move.
Thank you for sharing your feedback there, Mr. Johnson. And I think what's instrumental about that is, as engineers, one of the first things that we learn is lifelong learning. between certifications as well as changing standards in data and software engineering. I believe that we have to continuously go out and self-educate in a lot of different ways. And I think this is why the conference experience is so special, because we're having a conversation about beyond the layers, and there were experiences around things such as data science. I was in a data science with a young lady yesterday, and then I did neural networks with a young fellow earlier today. And some of those things that I was able to learn in those sessions piqued my interest as an engineer, that I can take back and adapt in my work environment, right? And so the most interesting thing is communities like this, or engineers like this, or calls where, or even just videos on YouTube where software engineers are showing their practices and principles, is the knowledge exchange that that grows professionals.
Yeah. And, conferences like this, work is one place to get that, but like you said, there's ways to get that outside of work too. So
I kind of appreciated a couple of years ago in Atlanta, we had a competition environment where they took the mentors and put them on teams with the kids. And so we had and they mixed the kids up. So there were different platforms that the mentors could learn from the kids. I mean, it was so yes, something like this is definitely an environment where you can grow. And I appreciate BDPA for it.
Yeah.
Absolutely, Mr. Johnson. Thank you for that. And thank you, Mr. Moore, for your presentation today about going beyond the layers. And I think that's an excellent role sometimes, where the parents and the kids, they have to work together, or the boss, or what they call it, undercover boss, right? Where the boss comes down and works with the workers for data to understand the processes and things like that. And I think a lot of those experiences are very valuable. So I thank you for saying that, Mr. Johnson. If there's any questions, please feel free to share right now. If not, I will say that we could wrap the session up. And I think this has been an excellent learning opportunity.
Yeah. Thank everybody for attending.
Thank you.
All right, awesome. Thank you, everyone, for joining. We certainly learned some great things today, talking about going beyond the layers. Thank you for the excellent question about entrepreneurship, Ms. Ballard. Thank you for sharing what your technology stack and moving in a lateral direction looks like. And thank you, Mr. Moore, for your wonderful discussion today, and for lending us your time today. Some of my personal key takeaways were lifelong learning and having the ability to go out and get that information. Also, being able to understand the layers of the software architecture that maybe you don't see. I'm certain that this group has some things that they can take away from it. There are a few other sessions this evening. I know at 6 p.m. we have a comedy show as well as a jazz show. Please tune in and look forward to anything look forward to more experiences on the agenda. And thank you all, and I hope you enjoy the remainder of your conference. Thank you.
All right. Thanks, everybody.
All right. Later. Thank you all.
Thank you.